Does anyone have any questions about any of the material or any administrative concerns? All right, if anything pops up, feel free to just ask me throughout the lecture or after discussion. All right, today we are going to go over linked lists. Before we begin, let's start with building up as to why we care, right? It's always helpful to know where these are useful. So when we have arrays, and we've worked with arrays before, right? We have blocks of memory that cannot change size. Because of this, their uses are fairly limited. We have been able to make factors, which are the standard libraries implementation of dynamic arrays, and it allows functionalities such as pushback and popback, which allows us to add to the back or remove from the back to allow us to have this dynamically sized array. But what if we wanted to insert something at the beginning here? Well, we would have to take this value and move it one to the right, as well as every other value in the array or in the vector, and then we can insert the one. So because of that, it's O(n) time to insert at the beginning. So how do we make a data type that supports insertion or deletion at the beginning? Well, to do that, we're going to use this linked list. The idea is that nodes point to the next value in the list. Before we even start looking more so at this picture, we want to say, what is a node? Well, we get to pick. We can make a struct, and we can make this called node. It can be have any values, any data types. So it can be char, it can be bool, it can be a string. And the important thing here is that it points to the next node in the list. So here, this would have a value of 1, and it would point to this node here. So how would we be able to find the first node? And how do we know we are at the last node? Well, at the last node, as you can see, there's no pointer here. So that pointer is actually a null pointer. And we're also going to be able to keep track of this first by making a class that calls this node pointer first. So that would look something like this. In our private variables, we have a node pointer to the first, and every single node in the list will have the pointer to the next node, so we don't have to worry about having a list of every single node in our list within our class, if that makes sense. So functionality we should support, we should be able to check if it's empty, see the first value, insert an element to the beginning, and delete an element at the beginning. So how would empty look? Well, here, this pink arrow is going to be our first pointer. If we're empty, there's nothing here. So this pointer is going to be null. So we want to return true in that case. If we have something in our list, this is not going to be a null pointer. So then we would want to return false. That looks something like this in code. You can see return first equals null pointer. If the first is null, then we return true and we're empty. If not, we are not empty, return false, which is what we want. Here we have front. We want to be able to see the value in the front. We have two cases. So let's start with the easy one here. We just want to be able to access first value, which is pretty straightforward. But what if we are empty? Well, we don't want to access this null pointer. So we're going to make an assertion at the beginning. Assert we're not empty. And then if we're not, then first value is what we're going to return. So here we want to push a value to the front. So what that would look like in here, in this case, is we would make a new node, have it point to our current first, and have our first point to that new node. So that would be done in one step. It's kind of tricky, but it's pretty cool. And then if we're empty, we can just make a new node and have our first point to it, which is pretty cool. So that would look something like this. We have a new node with the value that we pass in, and that points to the first for the next node, and the first node should be this new node. All right. So now we have pop front. Pop front's a little tricky. So first, if we're empty, we don't want to access the null pointer again. So we will do it on an assertion at the beginning once again. So does anyone have any ideas? Okay, so I heard we can just delete head, right? So if we just delete head, oh, we can't access anything in the list now. So that would be bad. What we want to do is, first we want to be able to set this head pointer here. So if we just did that and then we delete the head, well, then we have all this memory leak as well, and that's no good. So we're going to put that back. So now this is the actual solution that we're going to want to use. We're going to make another pointer to this values pointer and then increment this arrow up. And then we can delete this pointer, delete this node. And so this is the exact linked list we want. That would look something like this. Node first. First is now the next. The old first node's next, and then we can delete the victim. So now I want you guys to try to do it on your own, but now make a doubly linked list. What this would look like is we have nodes here that are both linked back and forth. We have a first pointer here and a last pointer here. And this one would point to null, and this would have a previous pointer to null. And implement these functions. If you guys have any questions, please let me know.